Hi everyone, Mr. Neighbor here, and we're still talking about simple machines, specifically the wheel and axle. So we have one last problem before moving on to the next simple machine. We're calculating the mechanical advantage of this wheel and axle simple machine. The wheel on a toy car is 1 centimeter in diameter. The diameter of the axle, which is attached to it, is 0.1 centimeters in diameter. What is the ideal mechanical advantage of the toy car? So we have to take the radius of the wheel divided by the radius of the axle. So remember, our labels are going to cancel. So it doesn't matter what our labels are. Centimeters is fine. Mechanical advantage is only a number. So I will have 0.5 centimeters for the radius of the wheel divided by 0.05 centimeters for the axle. And when we do that, we will get out 10. So that is our mechanical advantage for this problem. All right, next simple machine. Simple machine number 3. First we had levers, then we had wheel and axle. Now we have pulleys. So a pulley consists of a rope that fits into a groove in a wheel. It's classified by the number and arrangement of wheels and ropes. So first we have fixed pulleys. They simply redirect the force. Whatever you put in is whatever you get out. So if you have a 100 Newton thing here, you have to pull with 100 Newtons to get that force to lift that object. It just redirects it. Movable pulley. Movable pulleys have 2 things supporting this weight. So that means that you only have to apply half the force. So if this was 100 Newtons, this string would hold 50 and this string would hold 50. So you only have to pull 50. However, you have to pull twice as far to get it to move a certain distance. So if you want it to move 1 foot, you have to pull 2 feet, although you don't have to pull as hard for those 2 feet. So your choice. And everything after that is usually called a block and tackle, where you have some pulleys that are fixed and some pulleys that are movable. And looking at how many strings support the weight tells you how much work you have to do. So I have 1 string right here supporting the weight. I have another right here that is attached to the movable wheel, and then a last one right here. So that's 3 different ones. So my work needed to lift this 100 Newton block is cut in thirds. So it only require about 33 Newtons of force. I would have to pull it 3 times the amount though. So if I wanted it to go up 3 feet, if I wanted to go up 1 foot, I would have to pull it 3 feet in order to do that. But again, less work. That's what we're going for, less work. So some more in depth. The fixed pulley is a wheel attached to a point, allowing the wheel to spin in place. It changes the direction, but not the size of the force. So this is just a mechanical advantage of 1, what you put in, what you get out. A movable pulley. This gives you a mechanical advantage of 2. It rises and falls as the load is moved. It changes the direction and the size of the force. It creates a mechanical advantage equal to the number of ropes supporting the load. So this rope is supporting it, and this rope is supporting it. So we cut the weight in half. That gives us a mechanical advantage of 2. And then the last one are combined pulleys, also known as block and tackle. So you have your fixed pulley, you have a movable pulley, you might have a bunch of them together, and they create a greater mechanical advantage by changing the size and force and the direction, the size of the force and the direction. So this one, for example, gives you a mechanical advantage of 3. Others will give you a bigger mechanical advantage because it's supported by 1, 2, 3 different forces. All right, so the mechanical advantage of pulleys depends on the number of strands of rope directly supporting the load. So the object will only move 1 divided by the mechanical advantage of the distance the import force acts upon. So this is probably the best picture I have for you. If this is a a block and tackle, essentially, you have 1, 2 different supporting strands. So that means your mechanical advantage is 2. So the object will only move half. 1 divided by 2. That's a 2 now, because remember, this mechanical advantage is 2. So your object will move 1/2 of the distance the input force acts. So if it acts 1 meter, the object is going to move half of that, half a meter. So just remember that. This one right here, this is it's the same as right here. 1, 2, 3 strands. So that means the mechanical advantage is not 2 anymore, but 3. So the object will only move 1/3 of the distance now that the import force acts upon. So if this moves 3 feet, it's only going to be raised 1 foot. Very important to remember that. Pulleys are awesome, but you just need to remember what you're gaining in ability to do work, you're losing in the distance. All right, so that was simple machine number 3. We have levers, wheels, and axles, pulleys, and now we're on to inclined planes. Very, very simple. It's just a slanted surface used to raise an object by decreasing required force, but increasing distance it must move. So, for example, ramps, stairs, and ladders. Mechanical advantage of inclined planes can be calculated by taking the length divided by the height, and it usually comes out to be greater than 1. So this is our length right here, and this is our height right here. The problem with inclined planes is usually they're accompanied by something called friction, and that makes it a little bit more difficult. But if it was just frictionless, inclined planes are great because it reduces the work by a significant amount. So let's do some examples. Find the mechanical advantage of a ramp that is 6 meters long and 1.5 meters tall. So we take the length divided by the height. So length divided by height. The length is 6 divided by the height of 1.5. How many times does 1.5 fit into 6? 4 times. So you have a mechanical advantage of 4. A civil engineer must design a wheelchair accessible ramp next to a set of steps leading up to a building. The height from the ground to the top of the stairs is 3.5 feet. So let me just write that in, 3.5 feet for the height. Based on the ADA codes, the mechanical advantage of the ramp must be at least 12. So what is the minimum allowed distance for the ramp in order to meet the ADA? So I need to find what the length is. So I will multiply the 3.5 times 12. So the length must be at least 42. If it's more than 42, then that means I will have a mechanical advantage of more than 12. So it could be 42. Oops, I did that wrong. Greater than or equal to 42. Oh, nope, I did it right the first time. Sorry. The length must be greater than or equal to 42. Sorry. The fifth simple machine is the wedge. It's a modified inclined plane used to separate or hold things in place. A wedge turns a single downward force into 2 outward forces. You can see this most notably with the axe piercing the wood because of the different sides of the axe. For example, axes are wedges, door stops, or nails. And lastly, of the simple machines is the screw. It's an inclined plane wrapped around a cylinder. So the mechanical advantage is calculated by divided by the number of turns per inch. So for example, you have bolts, a peanut butter jar, a winding staircase, screws are everywhere. So those are the 6 simple machines.